Welcome, my viewers, to another interesting lecture on the group 15 elements, also known as the nitrogen family. Don't forget to subscribe, like, comment, and share this video. The objective of this lesson are as follows: to identify the elements in the group 15 of the periodic table, write down their electronic configuration, describe their periodic trends, and to identify the oxidation states of some compounds of the group 15 elements. Let us look at the properties of the group 15 elements. The group 15 elements are nitrogen, phosphorus, arsenic, antimony, and bismuth. Their atomic symbols: nitrogen is N, phosphorus is P, arsenic is As, antimony is Sb, and bismuth Bi. Their atomic number: for nitrogen is 7, for phosphorus is 15, for arsenic is 33, for antimony 51, and bismuth 83. And then we notice that the atomic mass increases down the group. We also notice that the valence electronic configuration is ns2np3. So they have 5 electrons in their atomos shell, and they have a completely filled s orbital and partially filled the p orbital in their atomos shell. For nitrogen, it has a filled helium shell and then 2s2, 2p3. For phosphorus, it has a filled neon shell and 3s2, 3p3. For arsenic, it has filled argon shell with 3d10, 4s2, 4p3. For antimony, it has filled krypton shell, 4d10, 5s2, and 5p3. And then for bismuth, it has a filled xenon shell, 4f14, 5d10, 6s2, 6p3. The property of the group 15 elements continues. The group 15 elements, nitrogen is a non-metal, while phosphorus is also a non-metal. Arsenic is a semi-metal, antimony is a semi-metal, and bismuth a metal. So we say that metallic trend increases down the group. Their melting point: we see a very high melting point for arsenic, 817 degrees centigrade. Because arsenic is a metalloid, so it is a point of inversion of the strength of interaction. Hence, the melting point increases up to arsenic and decreases down to bismuth. We also find out a high boiling point for antimony. This is because all 5 electrons of antimony engage in bonding, so it's difficult to break the bonds. The density increases down the group. Atomic radius also increases down the group. First ionization energy is highest for nitrogen and least for bismuth. So first ionization energy decreases down the group. Ionic radius increases, but the least is arsenic. And while electronegativity decreases down the group. How do they react? The elements of this group, how do they react? They react with oxygen to form NO2 and NO for nitrogen. They form P4O6 and P4O10 for phosphorus, and form AS4O6 for arsenic, Sb2O5 for antimony, and Bi2O3 for bismuth. Their type of oxide: for NO2 is acidic and NO is neutral. And then for the phosphorus, it forms acidic oxide. For arsenic, it forms acidic oxide. And for ferric oxide for antimony, and basic for bismuth. Reaction with nitrogen. Most of them do not react with nitrogen. Their reaction with halides. They can form halides of S3 and S5, very common with the elements of this group. And then their reaction with hydrogen. For nitrogen, we form ammonia. For phosphorus, we form phosphine. For arsenic, it will form arsine. For antimony, it will form stibine, and bismuthine for bismuth. For phosphorus, 4-oxide, that is the oxide of phosphorus, is an excellent drying agent for gases and solvent and for removing water from many compounds. Important to note. The element and sources of preparation of the group 15 elements. For nitrogen, the source is air. It said that air contains about 78% of nitrogen. And then the method of preparation is through liquefaction of air. Phosphorus are obtained from the phosphate rocks and from fluorapatite. And elemental phosphorus can be obtained from the reaction of phosphate minerals with silicon dioxide as sand and coke in a furnace of about 1500 degrees centigrade. Arsenic the source is arsenoprite, and heating arsenoprite in the absence of air will obtain arsenic. Antimony, the sources are stibnite. When we roast stibnite in air, we form antimony trioxide, and then the reduction with carbon will form antimony. And bismuth is from bismuth or bismuth glands. Roasting of bismuth, in air forms bismuth trioxide, and then when we reduce with carbon, we form bismuth. Covalent bonds. Covalent bond forms. This group can form covalent bonds because their outermost electron is 5. So it is easier for them to share electrons. They can share among themselves. That is what we observe from nitrogen here. Nitrogen is a non-metal, and a nitrogen atom has 5 electrons in outermost shell. And we know that 2 nitrogen atoms will each share 3 electrons to form 3 covalent bonds and make a nitrogen molecule. And that is what we have on the board there. If they share their electrons, they have formed a nitrogen molecule with 3 bonds. By sharing the 6 electrons, where the shares touch, each one of them bringing one electron. So they have shared 6 electrons. Each nitrogen atom can now count 8 electrons in its outermost shell, as shown in the diagram. If you notice the 3 atoms, this shell now, it has formed 3 bonds. 1 electron here, 1 electron there, and then 2 electrons will form 1 bond. And since there are 6, they have formed 3 bonds. In the case of phosphorus, phosphorus can also form covalent bonds as in PCl5 and PCl3. Phosphorus can form such bond in the arrangement of a pyramidal shape for PCl3 and a trigonal pyramid for PCl5. If we look at the PCl5 in a 3D format, we find out that the angle between an axial and equatorial triangle is 90 degrees, and then which makes the angle between the 2 axial atoms to be 180 degrees. And then the angle between the 2 equatorial atoms is 120 degrees. The oxidation state of the group 15 elements. The most common oxidation states of the elements of this group are -3, +3, and +5. -3 oxidation states can be found in phosphine and ammonia which are hydrides of phosphorus and nitrogen. We use phosphine, pH3. Phosphine is a non-metal hydride. So in this compound, hydrogen has an oxidation state of +1. Assuming we don't know the oxidation state of phosphorus, we can be told to find the oxidation state of phosphorus. We'll put this equation, X, which is what we do not know, plus 3. The 3 there represent the 3 hydrogen, times 1, which is the oxidation state of hydrogen itself, is equals to 0. This is because the sum of the oxidation state of a compound or a molecule is always equal to 0. So we must add that equal to 0. Then we'll say S plus 3 equals to 0. So what will be the value of S? S now will be equals to -3. That is how we find the oxidation state of phosphorus in that compound. Then we look at the oxidation state of +3. Oxidation state of +3 we can find in compounds like arsenic trioxide, nitrogen trichloride, and phosphorus trichloride. Let us use nitrogen trichloride as an example. In nitrogen trichloride, the oxidation state of chlorine is always -1. So we'll say S plus 3 times -1, which is equal to 0. S minus 3 is equals to 0. S is now equal to +3. We can also find the oxidation state of +5 in some compounds like nitrogen pentaoxide, arsenic pentaoxide, antimony pentaoxide, triazonitric 5 acid, and metallic phosphoric acid, HPO3. Let us use HPO3 as an example if we are told to find the oxidation state of phosphorus in this compound. We know the oxidation state of oxygen is always -2, and then it is 3 oxygen that is there. So we'll make sure we present the 3 oxygen. So we write 1, which is the oxidation state of hydrogen, plus X, which is what we are looking for, the oxidation state of phosphorus, plus 3 times -2 will be equals to 0. 1 plus X minus 6 is equals to 0. So X will be equals to +5. The allotropes of this group 15 elements, most of the group 15 elements form allotropes, and for nitrogen, it has the alpha nitrogen and the beta nitrogen. For phosphorus, it has 5 allotropes: white phosphorus, red phosphorus, black phosphorus, violet phosphorus, scarlet phosphorus. And for arsenic, it has black arsenic, gray arsenic, and yellow arsenic. Antimony has yellow antimony, metallic antimony, and explosive antimony. It is only bismuth in this group that does not form an allotrope. Only bismuth that doesn't form allotrope. Facts about nitrogen. What are the facts about nitrogen? Nitrogen is one of the most important elements of this group. It is the most abundant element in the Earth's atmosphere. It makes up 78% of the troposphere. It is colorless, odorless, and non-toxic. But nitrogen cannot be absorbed directly by the plants and animals until it is converted into compounds they can use. Our genes, we know, are made up of nucleic acid, DNA, which is deoxyribonucleic acid, and RNA, ribonucleic acid, is involved in protein synthesis, which require nitrogen. We all know that we wouldn't be alive if it weren't for DNA. The human body needs nitrogen for healthy food digestion and growth. It plays a crucial role in the development of the human fetus. You know, we know that nitrogen is an essential nutrient for the production of amino acids, protein, nucleic acid, and stone fruit trees require an adequate annual supply for proper growth and productivity. Nitrogen is primarily absorbed through fine roots as either ammonium or nitrate. The human body comprises 3% nitrogen by mass. It is an essential part of amino acid, which makes up protein, and it is nearly impossible to live without nitrogen. No nitrogen, no food, no life. What is the importance of phosphorus in human body? Another essential element of this group is phosphorus. About 85% of the body's phosphorus is in bones and teeth. And phosphorus is also present in smaller amount in cell and tissues throughout the body. Phosphorus helps filter out waste in the kidneys and plays an essential role in how the body stores and uses energy. It also helps reduce muscle pain after a workout. Phosphorus is a fundamental constituent of animal and plant matter. Phosphate groups are constituent of nucleic acid, that is DNA and RNA. Around 60% of bones and teeth are made out of phosphates. Phosphoproteins are available in egg yolk, milk, and bone marrow. And we know that these are very important food for the body. Applications of group 15 elements. Two of the elements, nitrogen and phosphorus, are required to survive all living things. The majority of the Earth's atmosphere is made up of nitrogen gas, and nitrogen is in much abundance in the troposphere. Phosphorus is useful for matches production, protectives, and fertilizer, and also for the production of phosphoric acid. Arsenic, one of the elements, is a toxic element, poison, and a rodenticide. Antimony is used in the production of alloys, while bismuth is used in pharmaceutical paint and as a catalyst. Study questions. Question 1. Find the oxidation state of nitrogen, phosphorus, and arsenic in the following compounds: NH3, B4O10, and As2O3. 2. List two allotropes, each of the group 15 elements and their uses. And then 3. Give 3 reasons why we say no nitrogen, no life. Thank you very much for listening to the end of this video. Don't forget to subscribe, like, comment, and share this video. See you in the next class.